Good morning, good afternoon, good evening, wherever you are. Just a little bit about myself. I am Vishnu Dutt, working in Cisco for some of the enterprise customers, and my passion is to create a network uh, for some of the customers, some of the enterprise customers, right? And the another passion is which I really like most is sharing my knowledge, is teaching, and that is where I am into the session. So having said that, let's start with a promise, right? I want to promise you one thing. If you complete this complete course, right? The complete course is going to be of 24 hours duration without any hands-on, because for hands-on we will be providing you as a separate videos, right? But yes, during this course we will be seeing vManage, vSmart, how to bring up, and so many things. So if you do this course, right? Uh, After completing 24 hours, I promise you, you will be capable of designing any SD-WAN network from scratch. It doesn't matter that if you have an experience of 2 years or 6 years or 10 years or 15 years, you all will be in the same race that you can design, you can talk about SD-WAN proposition value to any customer, right? But believe me, if you want to design a network, the fundamentals of this technology is going to be crucial for you. So that is why in the initial, in the starting, what we can say, 16 hours, we are going to learn all the fundamentals related to this technology. We will be going into the depth. We will be understanding everything, and then in last 8 sessions, we are going to design and have some talk about migration. Okay, so as you know that you are going to see always the brownfield deployment, means you are not going to see the greenfield one. If you do not understand these terms, do not worry. Let's discuss the agenda. What is the agenda of session one, right? We are going to start this session from absolutely scratch. Nothing is there. If you do not know anything, that's perfectly fine. So we are going to begin with what exactly wide area networking is, right? Then if you want to understand a particular thing, it is always good to go into the history of it, that how this technology have been evolving, right? So we are going to see the history of WAN, maybe last 20-25 years, how it is evolving, and then you will be amazed to see that how SD-WAN is going to add value in all this, right? So we will be talking about history of the WAN. Then we are going to discuss, this is the crucial part, right? If you haven't seen an enterprise till yet, right? If you haven't seen the WAN infrastructure of an enterprise, then it is difficult to design the WAN, right? So what we are going to do is we will take an enterprise network, right? We will take a typical enterprise network, and then we are going to talk about what exactly that network contains. Okay, so you are pretty much familiar about how a typical enterprise look, and if you are familiar about that network, then basically you can think of that what exactly WAN is, and then how you can improve that WAN infrastructure with SD-WAN, right? If you understand why we have introduced software defined wide area networking, you need to understand what are the problems we have in current enterprise network, right? If you understand the problems, you can think of a solution. And if you're thinking a solution, then SD-WAN should be there in your mind, because it is actually solving the problem of the legacy WAN, right? As I mentioned, if you know the problem, we are going to discuss the solution, and then more probably in this session, we are not going to introduce any terminology related to SD-WAN or VIPTELA, right? Because I personally believe, right, first start learning from the general perspective. So this session is not dedicated to Cisco or VIPTELA. This session is going to be for any vendor, whether it's a Silver Peak or anything. you need to understand that everyone is doing that overlay and underlay concept. So what we are going to do, we are trying to understand that why they are choosing SD-WAN and why they have chosen some specific methodology. So what we are going to do is we are trying to think that SD-WAN is a puzzle. We will break it into multiple pieces. We will try to understand the piece, and then at last we are going to put all pieces together to build a complete solution. So it might be the case that this last point we cannot cover. We might not cover in this, but I have written is that if time permits, we are going to cover this. We are going to combine all the pieces together. The session is going to be really, really interested. So let's start. Let's begin with first board, which is wide area networking. And what is wide area networking? So most of you guys might be having a feeling that why this Vishnu is teaching all these basic things, right? But believe me, when we go through somewhat details of all these things, right, you will be amazed to see that yes, this thing is actually required. Okay, so first thing first, what is wide area networking? So I will take an example that I have a person whose name is Rahul, or maybe we can take anyone from this training audience. Maybe we have Mr. Parth here, say, and Mr. Parth has a business mindset, right? So if he's a business mindset and he recently opened a company whose name is ABC Sports, suppose, right? And what this company does, his company creates sporting goods, right? His company, so in India, basically cricket is one of the sport which is liked by everybody, right? So he is creating so many things into the cricket, but he is also doing so many things in other sports also, like football, like badminton, tennis. So he is producing those sports goods, right? His business, because his quality is very good, the business equipment quality is very, very good. That is why a lot of people across India are showing interest in abc.com, which is creating the sporting goods, right? So what Mr. Parth is doing, Mr. Parth is saying that, okay, I have built the company. Now I want my employees to come to a particular place so that they can collaborate with each other, they can talk with each other, and then basically we can have a meeting, right? So he's inviting all of his employees in towards a particular, you can say, space or area, and he's calling that area or the building as the campus, right? And what exactly he has in campus? Because his building, because his company, he has recently started. So what he did in the campus, he bought some servers, right? 2 or 3 servers he bought. On one of his server, he is running his company's website, which may be abc.com. And why he is running abc.com? Because somebody from internet, if it wants to access this abc.com and want to order some of the sporting goods, then he can log into this server and order, right? But along with that, he also has some more servers in which he is running some applications, and maybe the simple application will be file transfer application, right? What is the use of it? For example, suppose this employee is A, this employee is B, and A wants to share a file with B, which is pretty large. So generally what happens, A is logging into this server. He is putting his file, maybe file 1.txt or JPG into this folder, and Mr. B is again logging into this folder to get that file. It's a simple thing which you all know, right? But this complete architecture of this complete building, whatever Mr. Parth is creating, is just nothing but its campus network, right? So in a typical enterprise, generally you see a campus network, right? So, but the problem is this campus network of Mr. Parth is in Delhi, right? Delhi is the capital of India. So Mr. Bath is from Delhi, suppose, and he has opened this campus in Delhi, and he is inviting all of his employees to come there, to talk, to collaborate, to use the file, and then he has also make his site public to everybody so that they can come and log into this site and order whatever they want, whatever the goods Mr. Parth is creating. Everything was going pretty smooth. But here you go, Mr. Parth business is going like crazy, right? So what he's doing is there is a lot of requirement from Mumbai, which is financial capital of India. There is a lot of requirement from Bangalore, right? There is a requirements from Chennai also. These are the major cities, major cosmopolitan cities of India, right? And there are so many requests from all these places. So Mr. Parth, what he's trying to do, he is opening the branches in this part of the India, means Mumbai, Bangalore, and Chennai. So there is a problem. What is the problem? Because employees who are coming to these branches, maybe suppose this employee number D is in branch 1, which is Mumbai branch. What if this employee also wants to connect to this file server and want to retrieve some of the files, right? It means that there must be connectivity between Mumbai campus and the Delhi campus. So any technology, so I'm drawing a cloud, any technology which is right here, which is connecting this branch to this campus. And believe me, the distance between Mumbai and Delhi is approximately 1100 kilometers, right? We are talking about distance here. Any technology which is connecting campus with branch, that comes into the area of wide area networking, right? So as Mr. Parth business is growing, he need this wider area networking, right? So I think everybody is on the same page with respect to wide area networking. And then, of course, he wants to connect the branch 2 also, branch 3 also, and so on. Maybe he want to connect branch 1 with branch 2 also, right? So that they can directly talk with each other. So generally, most of the companies, to save cost and to implement security policies, they ask the branches to come to the campus first or data center first, and then they reroute the traffic toward other branches. But right now here, there are companies in which branches can talk together, right? Without the intervention of campus. So branch 1 can talk to branch 2. It depends on what Mr. Parth wants, right? What business wants. So I am saying Mr. Parth is analogous to big business because he has started this company. So I am repeating once again, any technology which is into this cloud and connecting multiple branches and campus together, which are far away, comes under the umbrella of wide area networking, right? Sorry for this. So let's see how this WAN have been evolving over the years. Okay. So the problem is going to be same. The problem is Mr. Parth, just wait. Extremely sorry for this. So Mr. Parth, which is right here, he has his campus right here. He has some of his branch in Mumbai, Bangalore, and Chennai, right? So Mr. Parth is dealing with a problem that he wants to connect campus and branches together, which are pretty far away, right? So he is exploring some of the options, and somebody told him that there is a service provider who can solve your problem, right? So there is a guy who is a service provider, and this is this guy. So here we have Mr. Parth. This is the service provider guy. Mr. Parth goes to service provider guy and asks, I want to solve one of my problem. Service provider said, what is your problem? Then he said, I have many branches across India, and I'm giving example of only 3 branches, right? I want to connect those branches with the campus. My campus is in Delhi. Can you help me with this, right? So what we are going to do here is we are going in from the beginning. From the beginning means let's go 10, 12 years back, 15 years back and see. Although lease line concept is right now available also, but let's see what are the solution cost-effective solutions also, which service provider is providing. But now, when Mr. Path went to service provider first time, service provider is saying, okay, I can solve your problem pretty easily, right? If you really want to connect your branch with campus, you can take a wire from me, which is going to be dedicated to you and which is going to connect your Mumbai branch with campus. So this wire, right? He's saying it is a leased line. This is totally dedicated to you. And if you buy that from me, right, your problem is going to be solved. Your campus and branch are going to be connected. So by the way, guys, if I say that branch is connected to campus, what is the meaning of that statement? The meaning of the statement is, suppose these two servers are part of a subnetwork, which is my x.x.x.0/24. Suppose, right? And here, this branch user is part of a subnet, which is y.y.y.0/24. Suppose, okay? And if I say the branch one and campus is connected, the meaning is I am successfully able to reach to this subnet in campus from branch and vice versa. And how I'm going to reach to this subnet? If my branch one knows that where the route is x.x.x.0, which is inside my campus, how to reach that? Via what? Right? Similarly, if I have a route in campus which says y.y.y.0/24 is reachable via something, right? And if I have these routes, uh, and if I have these routes installed into my routing table of campus and branch, then they can communicate. So it means that service provider is saying just place one router here, and on these interface you can configure the IP address. Maybe this IP address is say a.a.a.a, and this IP address is b.b.b.b. So it is the responsibility of service provider that if you do a ping from b.b.b.b to a.a.a.a, it is going to ping, and that is the functionality of this leased line. So it doesn't matter how this line is implemented, is installed by service provider, but he's saying this complete leased line or this wire is totally dedicated to you. You can attach this line to your routers and then you can configure IP address on them. And if you can configure IP address on them, those are going to be reachable. And he's saying it is as good as if you are connecting two routers with each other, maybe R1 and R2, right? And you can give them this A.A.A and B.B.B can be part of the same network. So means these are directly connected routers. It is as good as that somebody as taking 1100 kilometer wire or Ethernet wire and connecting it to your routers, right? So the distance is 1100 kilometer, and now when you specify IP address on this, you can run any protocol, right? Maybe you can run OSPF here. And if you are running OSPF, then basically what you are going to do is you are going to advertise x.x.x route into OSPF, and from here y.y.y route into OSPF. Once done, campus knows about branch one knows about campus, and they can easily communicate. Very, very easy concept of leased line, right? Now the problem is Mr. Raul is saying, okay, you have connected my branch 1 to campus. Can I do the same thing for branch 2 and branch 3? He's saying absolutely, connect them with a leased line. But what is the problem? The problem is these leased line are costly, right? And you can see if it is a point-to-point solution, it is going to take too many interfaces on your router, right? So suppose here, if I say this one is router 1, it is going to take 3 interfaces to connect this, and it is really pretty costly also, right? And that is why some more technologies come into picture. For example, we were talking about leased line. Now, after leased line, basically, if I go into the history, then we have ATMs and frame relay. So one story, basically, when I was giving my CCI exam approximately 7 years back, right? This frame relay concept was actually there. Frame delays also come under to the WAN technology because its responsibility was to connect branches or campus which are far away or anything which is far away, right? But believe me, you do not see them now in any network. So there is no point of discussing ATM and frame relay. But yes, I just want to mention you that lease line is a way which is still used by many companies, right? But there is another way which is ATMs and frame relay, right? But that technology is old. We are not going into that. So we are going to talk about MPLS now, right? So you must be arguing why I'm talking about these, right? The reason is whenever we try to understand SD-WAN, right, there are different transport. Transport is just nothing, whatever we are discussing. Lease line is a transport. Why transport? Because it is transporting our information from campus to branch or vice versa, right? So in SD-WAN concept also, we are discussing transport, various transport. It doesn't mean that you need to understand each and every transport, right? But we are giving you the information, the pretty high level information that what exactly or how exactly a particular transport works on a pretty high level so that it is not going to be problem for you. So it doesn't mean at all that if you do not know MPLS, you cannot understand SD-WAN. You can, right? So let's see. Let's try to discuss what what's again Mr. Parth problem is and how Mr. Parth is going to resolve it, right? So now Mr. Parth again going to the service provider and saying, you have solved my problem, but a big but is you are charging me a lot, right? Can you do something to reduce my cost? My requirement is same. I want to connect my branches to campus. Can you do this for me in slightly cheaper manner and the best manner? Service provider, oh yes, basically I have another technology which is known as MPLS. And what you can do is you can utilize my MPLS network to connect all these branches and campus together, right? So he is saying that now I have a cloud and the cloud name is MPLS and you can utilize this MPLS and share whatever information you want to share. What you need to do. So then Mr. Parth said, what exactly I need to utilize this service? He said that nothing is going to be changed. Whatever the routers you have campus site, it is going to be there. Whatever the router you have at the branch site, maybe this one is R1, this one is R2, it is going to be there, which is not a problem. What you are going to do is you connect these routers to me, right? And now it is my responsibility to suppose these routers may be router number R3 and router number R4. This doesn't come. These routers do not come under your jurisdiction. These routers are the responsibility of MPLS service provider, this service provider. So this guy is saying, perfect, you connect with me, you run any protocol of your choice. Maybe it's a OSPF, it's a BGP, interior or exterior, doesn't matter to me, right? You run any protocol, and now it is my responsibility to transfer your route from one location to another location. What is the meaning of that? The meaning is, suppose if you have one route in campus, x.x.x.0/24, right? And you are running OSPF neighborship or OSPF protocol between MPLS service provider and this campus. What you are going to do, you are advertising this route into the OSPF, and now it is a responsibility of MPLS service provider to take this route into its cloud and advertise it towards the branch. How it is doing, it is again a superb technology, right? Probably we are going to start a course on that too. I really love this technology, right? So try to understand what MPLS is doing. MPLS is taking your route and then advertises them into a particular branch or branches, whatever you have, right? So it is going to be here in this branch that if you want to reach x.x.x.0/24, you can reach it via R4, which is a service provider router, right? So if you create a packet here for x.x.x.0, you need to place that packet on this wire, and it's the responsibility of MPLS service provider to route this packet across, because here maybe many routers are attached in the service provider network, right? So it is the responsibility of this MPLS service provider to route this traffic in its network so that it can reach right here in the campus. How it is going to do, it is a very, very interesting topic, so basically MPLS works on label. We do not want to go into that, but for now, try to understand whatever your routes are. So if you connect this branch 2 also, if you connect with this branch 2, right, with service provider, maybe any router, again, you have here one router, you have this route maybe C.C.C.C.0/24, then you are advertising into OSPF or BGP, whatever you are running, right? It is going to be here, and then it's a service provider responsibility to make sure that it reaches to campus and other branches, right? But what is the catch here? Why service provider is giving you a cheaper solution as compared to leased line, which is doing exactly the same thing? This is the private network of the service provider. He is saying whatever you are creating, whatever your network is going to be, it is the private network, right? Just like lease line. So what is the catch here? The catch here is just like abc.com, which is a company of Mr. Parth, right? abc.com is a company of Mr. Parth, and they are utilizing the service of MPLS. It means that if I have this cloud, which is an MPLS cloud, it means that abc.com is connected to it, right? And whatever the branches of this abc.com, they are connected over this MPLS. So maybe you can say there is a complete network for you built over this MPLS, right? Similarly, other companies, maybe Cisco is connected to this service provider, right? So Cisco has its campus, maybe, let me draw it with the white pen, the campus in Bangalore, maybe other branches, right? So everything is also a private network for Cisco. It means that whatever the network, suppose if I have x.x.x.0/24 network of abc.company, it is the responsibility of the service provider that it should not go from abc.com to cisco.com, right? And many customers are attached to this MPLS cloud. It means that it's a shared environment which is giving you the feeling that it is your own private network, just like the cloud, right? So many enterprises, companies can connect, and it is going to be the responsibility of service provider to maintain that a route of a particular company should not go towards the route of another company. How it is going to do that, it is a very important thing. But yes, you can understand now, because this infrastructure is shared by many. That is the reason you are getting it cheaper, right? With that, I would like to take a pause here. If you guys have any problem till this point, you can ask. You can unmute, you can ask. Okay.
I don't have a question, but I would like to add something for the MPLS part, Vishnu.
Yeah.
If the customer, if the branch is running not dynamic routing protocol, they are running static routing with the service provider.
Yeah.
In this case, it's full dependent of the service provider configurations.
Yeah. Perfect. Perfect.
That's another hard subject for this kind of topology. It's full service provider dependent configuration.
Yeah, I understand. And thank you so much for this addition. So we can run static routing here also, and I have seen in my career that many of the customers are using it. So in this case, basically MPLS is taking that responsibility of advertising everything, whatever we have. So this is good part. So thank you so much, Burak, for this. But I think with overall understanding, you should be aware now that what exactly MPLS is. Now, Mr. Parth is running all these things for 1 year, maybe 1.5 year. Then some smart guy came to him, right? And he said, "You are using MPLS, Mr. Parth. You are using MPLS." So one another guy, he's a very smart guy. He's saying you are using MPLS, but believe me,
Sorry, Vishnu, can I add something?
yeah, please add. Okay, yeah, go ahead, Ted. Okay, am I audible, guys? Can anybody confirm I am audible?
Yes, yes, you
Yeah,
are.
I can hear.
Okay, perfect. Okay, so let me continue with this, and then in last half an hour, 15 minutes, when we are done with this, basically we can add few things, whatever you would like to add. But if a question is, just stop me. Okay, so if you see here, somebody came to Mr. Parth. He's a smart guy that you are using MPLS, and believe me, MPLS is also costly. So internet is everywhere. He said that we have internet everywhere. Why you can't use internet to connect your branches and campus? And he said that it is going to be a cheaper solution for you, and internet is also pretty good transport. So Mr. Parth is saying, okay, this is perfect. He again went to service provider and asked them that, man, I'm using your MPLS services, right? And it is working pretty good for me. But I have heard about an internet that can also connect my branches. So this guy is saying, absolutely, you can connect your branches with campus, and I can provide you internet service also, right? Then Mr. Parth was pretty happy with this, that okay, I am going to save some of my cost with respect to internet if I start using internet as a transport. So then Mr. Parth asked him, what do I need? Okay, then service provider said nothing. You are going to have the same infrastructure at your site. What you need to do is I am going to give you a cable, you connect it, and then you can run a protocol of you can run BGP over it, so exchange route, or you can do just the static routing, right? And this is my responsibility, my duty to connect this router R1 with R2, right? And how is he is able to do that? Because internet is just nothing. Internet, for example, every company was creating their own network, maybe network one, this is network two, and so on, right? If you connect all these network, all service providers network, and another network also, then basically whatever the structure you get is the internet, right? So it means that internet is not owned by any one service provider. There are multiple service providers which are connected, and we have lot and lot of routers which are routing your traffic towards a particular destination. So Mr. Service Provider is saying here that I have R1, you connect to me, and it is my responsibility. Whatever IP address, suppose IP address here is IP1, IP address here is IP2. If you connect them over the internet, right, then absolutely no problem. These IP1 and IP2 are going to be reachable, right? But now the problem is, can Mr. Parth utilize the internet to transfer his routes of campus, which is x.x.x.0 slash 24 towards this branch, right? To do that, he must need to run a routing protocol, right? Because internet is not going to do all this thing for him, right? So what he's going to do is he's going to run a routing protocol between R1 and R2. But here is my problem. R1 and R2 are not directly connected. So suppose Mr. Parth is saying, I was running OSPF previously. Can I run OSPF between R1 and R2 and exchange route? So the problem is R1 is here, R2 is here, and if you want to run a routing protocol, maybe OSPF between these two, what you are going to need? you are going to require that this R1 and R2 are part of the same network, or this wire should be directly connected with each other. And what I'm going to explain you in next 5 minutes is going to be very, very crucial, because we are going to learn concept of underlay and overlay, which is the problem for many guys, which is the most easy to understand concept. Just try to understand what I'm doing here. I have R1 at campus, I have R2 at campus. I want to run a routing protocol between them, but my problem is R1 and R2 is not directly connected. Although BGP doesn't have such requirements, BGP you can run, but right now, just try to understand. Mr. Mr. Parth wants to run only OSPF, which is the interior gateway routing protocol, which requires that R1 and R2 should directly be connected with each other, right? Which is not the case here. And if it is not the case, then we cannot run OSPF. OSPF neighborship is not going to come up, right? So there is a solution for this. Like some smart guy again said that, okay, you have taken the services, internet service, I can solve this problem for you. And uh, this is a network engineer of Mr. Parth. He's saying, pretty cool. I have the internet connectivity. Now this IP1, IP2 and IP1 can reachable over internet. What I can do is I do not have a physical link between R1 and R2, direct physical link, but I can configure a virtual link on top of it, right? And what is the virtual link? Virtual link I would like to showcase you with this green color. If you have a reachability between IP1 and IP2, this reachability is only required to create this virtual link up and running between R1 and R2. It is going to give you a feeling that R1 and R2 is directly connected, and we call this virtual link generally as a generic routing encapsulation, or GRE tunnel, right? It's a tunnel. Tunnel doesn't mean anything. Uh, it means that if you can give me the connectivity between IP1 and IP2, I can give you a sense, a feeling that these R1 and R2 are directly connected. Doesn't matter how many routers are between now, right? There are many routers, and if this link is not there, and all you need is the connectivity between this IP address and this IP address. If you can give me this connectivity, I can give you a feeling of a protocol, or I can give you a feeling that this link, this virtual link, is directly connected. And if this and if this is a directly connected link, what you can do is you can configure an IP address here, right? Where on this link itself, the newly created link, which you call the tunnels, right? So this is going to be a tunnel interface, maybe tunnel 0. This is going to be a tunnel interface, tunnel 1. And what you are going to, or maybe tunnel 0 here also. And what you can do is you can configure an IP address, maybe IP1 here and IP2 here in the same subnet. And then you can run OSPF protocol. And then you can share your route between campus and branches, right? So although you are running internet, but on top of internet, you are running a virtual circuit. So how is going to be your packet going to look like? For example, if you want to send an IP packet over this, right? Then basically you are not going to send it over the internet directly, because now you have a directly connected tunnel. So one thing, actually everything is going over this internet, right? As a normal IP packet. But whatever your IP packet is, you are going to introduce one more header into it, which is called GRE header. What is the meaning of it? We will discuss it later. The meaning is when this packet is reachable at this R1, it is going to see, okay, this is the GRE header, and it means that something is inside, right? Okay. So what exactly how this packet is going to look? I am just telling you that previously the IP packet which is generated by this host, suppose this host is this packet, what it's going to do is it is going to have GRE over it, and now it is going to encapsulate this complete GRE packet into a new IP packet which is going to have this address, right? Okay, I should say this is IP3, this is IP4, which are different IP address than this. So this is going to be the source IP address is going to be IP3, the destination is going to be IP4, and then basically if you are encapsulating one IP packet into another, that is nothing but your tunneling, right? If you do not get last 5 minutes also, believe me, we are going to discuss all these concepts again and again, but I want to make sure that everybody understand that if we are several routers away also, then also we can give a feeling that these two routers are connected with each other, and we can give this feeling with a technology called generic routing encapsulation, right? Actually, your traffic is going to be on this internet itself, right? But you have mentioned some of the things in this header so that this guy can understand the real IP packet is inside, right? Now the question is whatever you have built, this virtual tunnel, this virtual link, we call this virtual link as overlay. So your GRE is overlay, right? But to build this overlay, you need a certain infrastructure. You need IP2 connectivity with IP1. And who is providing that? Internet is providing that. So your internet becomes underlay. It is as simple as that, right? So whoever is providing you this connectivity is your underlay, and whatever the virtual link you form on top of it, that is your overlay. And believe me, all the new technology, whether it's application centric infrastructure, whether it's SD access, whether it's SD-WAN, they are just creating overlay on top of your underlay. If underlay is robust, overlay is robust, and vice versa. And not vice versa, sorry. So if your underlay is robust, your overlay is going to be there. If there is no underlay, if it's a problem in underlay, then basically it's a problem in overlay, right? Because overlay is built on this, right? So if you have any question, any doubt, you can stop me right away and ask your question, right? But now this smart guy again came to Mr. Parth. He's saying, this is very good. I have connected all of your branches over the internet. Everything is working just fine. Perfect. No problems at all. Right? But there is one very basic problem I have noticed. And the problem is all of your traffic is going on internet. Previously, when you were using MPLS, that was the private network. Nobody else can see that. But now, whatever you are sending over this internet, it is going as a plain messages. Anyone on the internet who has some capabilities, right? Who has some security knowledge, some knowledge where he can take your packets out, can take your packet out and read those packets. Whatever you are sending, confidential data, important data, and it can be stolen. And if it can be stolen, then it's a problem, right? And right now, whatever we are doing, we are sending everything in plain text. Anybody can read it. So there is a security issue. And that is where this guy suggested we are not going to send anything in plain text. If I say plain text, it is a plain message. Okay. And if I am not sending anything in the plain text, it means that I need to make sure if I change this packet, I need to make sure that it is not going to be readable by anybody on internet, right? Doesn't matter if it gets the packet or not. If he even gets the packet, he should not be able to make sense out of it. And that is where the new thing, which is IPsec, come into picture. The whole sole purpose of this IPsec is whatever you are sending, this IP packet, right? The GRE packet, whatever you are sending, what exactly it has, the IP packet, the interior IP packet from this branch, then it put the GRE header here, and then the outer IP packet. What this IPsec protocol does, it encrypt whatever is there so that if this guy can extract it, it is not going to make any sense to him, right? Which part of this GRE header is going to be encrypted, we are going to read about IPsec. We are going to give some good amount of time to IPsec and TLS in these series of videos. So do not worry about it. But Mr. Guys network engineer, Mr. Parth, network engineers suggested we are going to encrypt it, everything, whatever we are sending between campus and branches, because everything is going on plain text over the internet. Anybody can read it. And that is why he suggested using IPsec, right? So now Mr. Parth is happy that we are using internet, but sometimes this internet was not behaving properly because on internet you did not get service level agreements. What is those service level agreements? So previously when you were on MPLS, right, the service provider was saying that if any of your branch wants to reach to your campus here, I can make sure that the to and fro traffic path or the total delay should be, it is going to be less than 100 millisecond always. I am giving you this service level agreement. If I break it, you can charge me. But it is the problem with the internet that you cannot, nobody is going to give you SLAs because it is not under the jurisdiction of one service provider. Because many service providers are connected together, that's why you have internet. And if there are many service providers that you cannot give promises on the behalf of others or other service provider, and that is why the service provider is saying I cannot give you any SLA. I cannot promise you that you can always reach your branch. The delay between your branch and campus is always going to be 100 milliseconds or even less than that, right? So there is no SLAs. So Mr. Parth is pretty happy with whatever the structure they are running right now, the architecture they are running now, which is internet. But sometimes these employees come to Mr. Parth that my application experience is poor. I'm not able to access this application at all. Sometimes in a month. And if that is the case, then this smart guy is again suggesting, why can't we do this? We can take MPLS as well as internet, both the things, right? So whatever the important traffic, so if I go a little bit right here, and if I draw a router in the campus for Mr. Parth company, so what Mr. Network Engineer is suggested to this guy, CEO, Mr. Parth, that we are going to take both the services. We are going to take internet and we are going to take MPLS also. No problems at all. And what we are going to do, instead of buying a pretty costly circuit, what we are going to do, we will take it for some bandwidth, maybe 1 gig of bandwidth, and the internet is going to be 10 gig of bandwidth. So whatever the employees I have here, right, the most crucial data which is used, right, to access application or something, I am going to send it over this MPLS. That is it, right? But the other traffic means maybe these employees are busy in doing Instagram, Facebook or something, and he is suggesting that for such type of traffic, I'm going to use the internet, right? So this way, basically, Mr. Parth doesn't have to spend a lot in MPLS, but still, its company's experience is going to be pretty good. So this is the way how your WAN has been evolving. Then basically DMVPN technology comes, and if you give some injection to steroids injection to DMVPN technology, it will become SD-WAN, right? So the whole sole purpose of understanding this WAN history is that you know what are the various transports available, because IPsec GRE is what you are going to see in this SD-WAN or the DMVPN solution, right? So the final thing is the SD-WAN, which is right now, and what problem it is going to solve, we are going to discuss it, right? But I could see that there is a hands up from Raj Sharma. So Raj, why don't you ask your question now?
Yeah, I got clear because my question was that when we use IPsec, it's not that we are getting a stable connection.
I am extremely sorry, Raj, but there is a lot of disturbance from behind. I couldn't get your question. Or maybe what we can do is we can come up with your question again, right? When this disturbance is not there. Okay,
Okay. So
perfect.
construction work is going on
No
behind
problems,
me.
no problem. Maybe you can write down that question, and but the problem is chat is
Okay.
not enabled here. Or what we can do is we
Okay.
can take this question later on. No worries.
Okay.
Okay.
Thank you.
So now,
Hello, sir. Sir.
anybody else? Yeah, Parth.
Yeah, yeah. Sir, I have doubt this.
Yeah, first of all, congratulations to you
When
for your ABC Sports Company.
thank you,
Yeah,
sir.
go ahead now.
Yeah. So I wanted to ask that when we are going over the internet, right?
Hmm.
So what is the use of GRE then? What difference is creating? Like it's just the we are seeing it as direct connection from branch to campus, but what benefit exactly in terms of networking it's providing us? So why we are using this GRE over internet?
Okay.
I'm not able to get that point.
Okay, but you understand this thing that if you want to run a routing protocol between these routers, suppose R1 and R2, and suppose you want to run OSPF, suppose
Yes,
you agree with
yes,
me that you need to connect this link. This link should be on the same subnet, otherwise OSPF neighborship is not coming up.
right, definitely.
Hana. What is going on here is suppose on these red links, which is your internet link, right?
Yes,
Service provider is going to give you two IP address 1 and IP address 2. Okay. And these are
yes,
reachable. But those are not going to be on the same subnet. If that is the case,
okay,
you cannot run OSPF routing protocol over it, right?
okay,
And if that
okay,
is the case, you need something which can give you a sense like this. And GRE is exactly giving you the sense like this, that although there are multiple routers in between, but it is giving you a sense that these two are connected directly like this, right? Now,
okay,
on this tunnel link, whatever you have previously, this become your underlay, right? Because it is providing connectivity between R1 and R2. And now you can configure another set of IP address on this new link, new tunnel link, which is your IP, say 6 and IP7. And these two things can be in the same network because now this is the virtual link, right? So this is the beauty of GRE, and this concept is not new. We have been doing from so many years. And believe me, whatever these new technologies are, SD-WAN, SDXs, whatever they are just creating these overlays, and that is it. We just need to understand these overlays. The overlay can be different. In data center, this is VXLAN. Here we have GRE, right? SDX is basically we have VXLAN but with some other control plane mechanism. But the concept is going to be same. We are creating overlays over underlay. Okay. Hope I'm able to answer your question. So let's move towards new board. So now here, this board is again going to be pretty interesting. If you want to understand SD-WAN to its core, you need to understand how a typical enterprise network looks. Okay, here you go. So this is again Mr. Parth company, ABC, and in this company, Mr. Parth is evolving its networking, what we can say, networking infrastructure. So previously he has one campus, which is right here. You can see, right? There are so many employees here, branch 1, branch 2, branch 3. And now, again, some smart guy came to Mr. Path that it is beneficial if we can move all of our servers. Previously, as you have noticed that everything, all the servers were right here, right inside the campus. But now, as Mr. Parth company is growing, maybe you can have more than 50 to 100 branches across India. If you have that kind of setup, then it is always beneficial to put all these server to a location which is kind of accessible to everybody, right? Okay, so you have decided a place that you want to open one data center. You want to built one data center into Mumbai region where you are going to put every server of your enterprise into just one place, right? So data center is just nothing. What you have done is all of your applications which you were doing previously, right? Which were in your campus when your company was little bit what we can not that scale. Now the company is scaling up, so you wanted some structure into your company. So what you have done is you have taken all of your server from your campus and put them in data center. But once you put them in data center, you need to do networking of these servers, right? And if you want, previously, how come you were creating different VLANs here, right? And where do you create those VLANs? You create those VLANs on switches. That is why you need switches here. If you have these switches and if you want to go to another network, you are going to need a router also, right? So I am just specifically mentioning that how a typical data center look. What are the things in a typical data center? You have servers. You want to put them in, you want to segregate them into different VLANs, and that is why you have switches. Then these subnets, whatever you have created, they want to go and communicate to other subnet to outside also, and that is why you have these routers. This is your edge router, which is connected to internet as well as cloud, right? But the most important thing in the data center, along with whatever we have discussed, is these 4 boxes. And I believe by seeing these icons, you understand that this box is your firewall. And this box is your load balancer. Why exactly do you need them, right? So now all of your servers, so I'm just talking about a typical enterprise data center, right? Then we will talk about other things, but how a typical enterprise data center look, it is going to be very, very important, right? Because it is going to create a full picture of enterprise for you. Now, what I have explained, Mr. Parth has taken all of its server from the campus. They have put it into centralized location, which he is calling data center. To build the data center, he needs switches and routers and firewall also, wired firewall. So there are so many people on internet, so many, which are only there so that you cannot do your business properly. These are bad people, right? So your company website is running abc.com, and this guy whose whole sole intent is to just destroy this abc.com, he can do so many attacks on your abc.com. There are so many attacks, we can discuss about them maybe in some other lecture, other class. But now try to understand this intruder or this bad guy on internet can create problems to your business. So firewall is something which is capable of what we can say eliminating those threats which are coming from outside and sometimes which are coming from inside also. So bad guys are not always on the internet. Those are in your enterprise also, right? You never know from where this threat is going to come. But yes, this firewall can detect those threats, can work on those threats, and can eliminate those threats, right? So if there are so many guys, and you cannot just say that nobody can reach to abc.com because this is your business. People on internet, they are legitimate. There are going to be 100 or 1,000 of legitimate users which are going to access your website, which are coming from internet, going to this server abc.com, right? Want to order some of the goods from Mr. Parth companies, but there are some intruders also who are going to there for making sure that this abc.com is not working. So it is your responsibility to protect your data center. And that is why every enterprise has security team, right? The security team whole sole job is to configure this firewall so that so that it can provide you necessary functionality to block those attacks. So this firewall is going to say you are not permitted, Mr. because you are doing something bad to me, and you are permitted because you are a legitimate user. Okay, so firewall is one of the most crucial part of your data center because it is saving your data center from outside unauthorized access or inside bad intent traffic, you can say, right? So you understand the meaning of firewall now. And now let me introduce one more thing, which is the load balancer. So here you go. You can see load balancer here. You can see load balancer here, right? What exactly this load balancer is doing in your data center. So now, suppose you have built this infrastructure for only 1,000 users so that anybody on the internet, 1,000 users can come and access this abc.com without any problem. But as I mentioned, Mr. Path is doing great in his business. He is producing a lot of sporting goods, which is of value to customers. And that is why this 1,000 users became 1 lakh. Okay. And now there is a problem because Mr. Path infrastructure was only for 1,000. So what he did, he introduced one more server and he's running abc.com on top of it, or maybe 3 more servers, right? Now, whatever the users are coming from outside, there are many users, right? So what is the responsibility of this firewall or load balancer is? It is taking the request that, okay, he wants to access abc.com user number 1. I should send them to the server number 1. And if it is another request, I should send it to the another server, which is server number 2. The name itself say it is a load balancer, right? You are getting load from outside internet, so many connection requests. And now you know there are more than one server who can process this request. And that is why you are balancing the load across these servers. It is as simple as that. It is another piece which is required in your data center. So if now anybody asks you how a typical data center looks, so I believe on a high level, you should explain them. But now the technologies can be anything. If we go into the past, there are three tier architecture, access, core, right? If you go recently, then basically they have introduced VXLAN here. And why VXLAN? Because servers has some different requirement as compared to this laptops in campus, right? They have introduced, means if you do not want to do the normal architecture, the VXLAN, then there is an automated solution or software defined solution, which is ACI. Technologies could be different, but this is going to be the general how your data center should look like, right? So a typical enterprise contains or has a data center, then they have campus. If we talk about this campus, we are talking about the same thing. If you have this campus, of course, you are going to need these switches. You are going to need these routers. Why? Because these employees are connected with themselves. Or maybe you are going to use the Wi-Fi devices or access points, right? But what you have done is you have moved all the servers from here to a centralized location, which you are calling as data center, so that all of your branches can access it in an efficient way, right? So campus has a different infrastructure, switches, routers, which you can create, and there is a different kind of technology. You can have it here, similar 3-tier architecture. You can create VLANs, right? Or you can employ SD-Access, which is a software-defined solution from Cisco for this campus network. ACI for data center, SD-Access for campus, and the remaining thing, whatever is here right now, whatever you can see here, it is your wide area networking. And our most focus is not going to be on ACI side. It is not going to be on SD-Access side. We are going to learn WAN side. And that is why I have showcased you 2 transports here. One transport is MPLS. So Mr. Parth was pretty convinced that I should have MPLS link also, and I should have an internet link also. And similarly, you can see in data center, we have that. But there are many branches which are so remote that there is no MPLS service at all, right? Or those are pretty small branches. They do not need the both of the connections, MPLS as well as internet. So that is why you can see branch 2 and branch 3 only have internet connectivity, but branch 1, where there are many users, they have connectivity to MPLS and internet. It depends on business, how your typical branch is going to look like, right? If we do not have MPLS connectivity in that region, we are not going to have it in that branch. Or basically, if there is no requirement, only few people come into that branch, maybe 1 or 2 or 3 or maybe 10, depending on your business requirement, you are going to connect it only to internet and not to the MPLS, right? So this is how your typical enterprise look. Now we are going to discuss some of the traffic flows also. What is going to happen when a user in the branch wants to communicate to internet, right? So suppose we are having this branch here, right here, and the user of this branch wants to access the internet or maybe the cloud, right? So my company says, because I have only few firewalls available, that is what I'm going to do is I will be inviting you. First, you should come to data center. Then I see that whether you are capable of going to cloud or not. For example, you have put one server here, and this server is such that the branch 2 users cannot access this server, but branch 1 users should access this server. So what you are going to do is the traffic path is going to look from the branch 1 is it is going over MPLS, it is going like this, it is reaching data center, reaching to this firewall, and on this firewall you have created this rule. Okay, this is branch 1. Branch 1 can access cloud server, this server. So that is why it is going to send it like this. It is as simple as that, right? The second thing is the second traffic flow. Suppose you are saying branch 2 should not be able to access your cloud server. So although you are going all this way, you are again coming to this firewall, but on the firewall you have a rule that if some user is from branch 2, I am not going to give it permission to go and access my cloud resources, and that is why this firewall is going to deny this traffic right here. It is as simple as that. But the important point is, in most of the organization, all of your security policies are implemented in data center, right? And this is causing some of the problems which we are going to discuss, right? But now I see that it's already 1 hour. So what I'm going to do is let's take a break. Let's take a break of at least 10 minutes. And then we are going to discuss what are the problems in this enterprise network. Right now, you can see that if I say that this is the model which we have been using for so long, if in fact this is the model of right now typical enterprise network, you can see this is how a typical enterprise network works. But believe me, with this cloud coming up, this model is not working. The application experience is not going great. There are some challenges with respect to management and deployment. We are going to discuss all the challenges after 10 minutes, but till now, I presume that you understand how a typical enterprise network looks, how a typical flow looks. Between branch 1 and branch 2, you can say it is up to your policies that whether you want this campus can go directly and talk to branch 1, they can. Or you can have a policy that it should come to data center 1 and data center and then come to branch 1. So it is up to you how you are going to design your network. It is going to be the business need also, right? But this is how exactly a typical enterprise looks. It is as simple as that. Now we are going a little bit deeper into it. We are going to discuss what are the various issues, problems in traditional WAN, right? Because although there are problems in campus network, in data center also, but this course is all about understanding wide area networking and what are the issues in that wide area networking. We are going to discuss it. So what we are...
Sorry, Vishnu. In this topology, is it better to connect blue cloud scheme to the just internet Not the direct connection to the data center router.
Yeah, so
Is it
actually
better way?
I have one use case around that, so I have connected. So generally cloud should be connected to internet, but nowadays, as you can see, we are using carrier neutral facilities, colos and other things, which are going to provide us the connectivity directly into the cloud. So I have some use case around that. So there is a specific reason of doing that. Do not worry about it.
Okay, I see. Thank you.
Okay, so as we mentioned that now we understand this typical enterprise network, right? Now let's try to understand what are the problem in this typical enterprise network. What exactly happened when we introduced cloud in this network? So everybody was working fine. You understood the concept of how these campus users were accessing internet, cloud, how these were connected. But the main thing which you should understand is that everybody is coming to data center first, then they have the security policies applied there, right? And after that, the traffic is going towards internet or the cloud, right? This was the simple thing. So what exactly happening with Mr. Parth is that some of its users, right, in different branches in campus, this says that whenever they try to access data center uh, applications, maybe a app one is supposed here, which is running on this server, right? And this app is really critical to Mr. Parth business, right? And they say that sometimes they are not able to use the application experience is not good at all. And they are saying that it is not always the case. Most of the time during a month, everything works fine. But sometime, and there is no specific pattern also, but during a month, some period of time, maybe Wednesday, Thursday, they are not able to have the same experience of this application one. And believe me, if this application is a problem, accessing this application is a problem for users, Mr. Rahul's business is going to be, this is a problem for Mr. Rahul's business, right? So in any situation, Mr. Rahul doesn't want that this application experience is bad for any of its employee who is working on this application, right? But uh, many of their users, many of their employees, during a specific period in a month, they say that application experience is not good. So Mr. Parth said that he asked somebody to check into this issue and let him know as soon as possible what exactly going on, right? So right now, if you can see that on this campus, we have two transport. If I'm saying two transport, it means that I have two different way to transfer my message from campus to data center, right? One is through MPLS and the other one is through internet. It's very easy, very simple, right? So there are two paths, and let me showcase you both the path. One is over the uh, MPLS, which is like this, and the other one is uh, over the internet, which is like this, right? So when we investigated it further, this application has a specific requirement. The specific requirement was that this application is going to work if the to and fro distance, if the to and fro time between this user A and this application is equal to or less than 90 millisecond. This application has a specific requirement, right? If by any chance this has not met over a particular transport, then this application experience is going to be very bad, right? So what is going on? Uh, almost almost every day in a month, right? This MPLS provider was providing the SLA, which says that you can reach from this campus to data center within less than 90 milliseconds. No problems at all. But during certain periods where this MPLS provider is not providing that SLA to you, right? And you cannot continuously monitor this. You cannot say all the time that this is the case, right? And it is not the case that we do not have monitoring tools. We have, right? But still, it should be automated. You should not be always on the toes that whether MPLS is providing the service of less than 90 millisecond or not. But during some of the days, maybe in a particular week on a Thursday, service provider network was pretty busy, and this time the delay between this campus and data center, the delay between this data center and campus was approximately 120 millisecond, where on this MPLS circuit, right? And then after, so the problem persists for maybe 2 or 3 hours. After that, it was again 50 millisecond, no problems at all. And during the whole month, it was like this. Then again, after some time, it was 130 millisecond because of the service provider network congestion, right? Then during that period of time, when we notice the internet, although is also performing well, this is a 10 gig circuit, and internet sometimes gives the similar SLAs like internet, not all the times, but sometimes. But during this period of time on the Thursday, the internet was providing me approximately 70 milliseconds of delay. It means that on that Thursday, when this employee was pretty upset that he is not able to access this application, the application is not performing well. Although we have a better path to reach that application, we couldn't use it, right? And why we couldn't use it? Because suppose if this link goes down by any region, then maybe my protocol, OSPF or BGP or whatever I am running, is capable of shifting the traffic from this link to this link when anything bad happens to this to my primary link. So suppose my MPLS link was primary, it goes down, OSPF sees, okay, the link goes down, and now I have only one path available to reach the data center. And what is that path? The path is via internet, then it can go and everything goes fine. But here the problem is that the link is not down, the link is impaired. The meaning of impaired, it is not working to its potential because there is a problem with respect to MPLS service provider. This link is not performing well, and OSPF BGP does not take into consideration these delay values, right? They cannot say that, okay, OSPF cannot say that, okay, the delay between me and data center is less than 90 milliseconds, I should move to the other part. Wouldn't it be nice that somebody should be there who is tracking all these circuits, tracking all these SLAs, tracking all these delay values and shift the traffic accordingly? But that is not happening right now for Mr. Parth. So they go a little bit deep down, right? And they find out that there is a problem with respect to MPLS provider. They can charge MPLS provider, but at the end of the day, Mr. Parth is losing the business, right? So application performance can lead a business impact. We should be solving it, right? So we need, at least this is a current problem which we could see, right? The second problem is cloud connectivity and direct internet access. And that is why, Mr. Burak, I have drawn this cloud directly connected to data center so that I can explain you this cloud connectivity and DIA problem, right? So let's discuss our second challenge, which you see in current enterprise, which is cloud connectivity. So what exactly?
Sorry.
Yeah, go ahead.
Sorry, Vishnu. Is it possible to solve for the first problem, application performance?
Yeah, it is
Problem.
possible, and that is why, Mr. Burak, I have a new board altogether for this, how these issues can be solved. But first let's try to understand all the issues. If we can
But I don't mean by SD-WAN.
yeah,
By using traditional methods.
traditional method, basically previously before SD-WAN there is a technology called IWAN which could have solved it, but yes, I don't see anything which can, or the performance routing also could have solved it, but the configuration of performance routing and all these things are really a pain. Okay, although
I see.
yeah, all the solutions were there.
Uh,
Yeah.
uh, I think maybe we can implement some kind of embedded event manager plus IP SLA to track the performance of the underlay.
Yeah, we can do that, but
But I
yeah, go
agree
ahead.
with you.
Mhm.
But I agree with you. It's hard to manage, and also there is a problem for the monitoring side
Indeed.
of this kind of configurations.
Yeah,
I agree with you.
yeah, perfect. So let's talk about now cloud connectivity and DIA. And thank you so much, Burak, for your inputs. So we have an application which is running on this server. So some guy, again, we have Mr. Parth here. Some guy came to him that why are you spending so much on your data center? There is a dedicated team who is managing data center. Now, basically, we have cloud. You do not need to bother about power requirement, space requirement, rack requirement, cooling requirement, which is actually adding your operational cost to run your business, right? What you can do is you can move some of your server into the cloud, and that is what exactly Mr. Parth liked the idea about, right? And he has some of its of servers as a virtual machine running into this cloud, right? But everything is same. So what Mr. So Rahul actually is my another character from another series. So I have a habit of taking that name. But here we have Mr. Parth. So Mr. Parth, what he is doing is he has a direct connectivity into this cloud. So he has bought a direct connection, uh, which is slightly costly, but which is directly connected to its data center, right? So this cloud is directly connected to internet as well as data center. And now the important thing is, as I mentioned in my last board also, whatever the security policies you have, all your security policies are right there into data center. So these applications which you have moved from data center to cloud, right? Which you have moved from data center to cloud, these application, it is not the case that every user can access them. What users, specific user can access them is the responsibility of this firewall, whether the traffic should be allowed or not. For example, maybe branch 2 users should not access these cloud application, right? And that is why you have created your security policies in your data center. So exactly, to reach cloud, what is your traffic path? The traffic path is going to be, let me showcase you with the sky blue color. The traffic path from the campus is going to be, first you are reaching to your firewall. You are scrubbed against that firewall, means you will be seeing that, okay, you are a campus user. Your name is Mr. A. I could see a rule according in this firewall, which says that you have the permission to access this cloud application. And then you are going like this, right? But the problem is you already have a direct connection also, right? The direct connection is directly you can go to internet and you can access. And most of the times, I am saying, most of the times the direct path is very efficient, or efficient as compared to this long path via data center, right? But how do we solve this problem? Because why at the first place we are saying you should need to come to data center? The reason was security, right? The first and foremost reason was the security, and that is why you are forcing everybody to come to data center first. For example, is this user, it is somewhere remote, pretty far. right? And now you are asking this user also to come via this GRE tunnel over this internet to your data center, go here, and then basically check. Again, a long path. But you can see there is a direct path available. This user can go directly to, and I can show you the direct path with some other color, maybe maybe the gray color. It is going like this. It is can go like this, which is the shortest path, right? This is another problem in the current enterprise, because with the advent of cloud is inevitable now, right? Every company is moving most of its resources from its data center to the cloud, and now as a network engineer you should understand the cloud networking also, right? And believe me, what a network engineer should know in cloud, I have already created a series of 5 hours freely available on my channel. Just go and see that, right? And why I'm saying at the first class of this SD-WAN course is because in the last session, the 23rd or 24th session, right, of this, or 24th hour of this on this course, we are going to talk about cloud on RAM solution for SD-WAN. It is going to be great if you just see these 5 hours of video. These are from scratch. If you do not know anything about cloud, you should see this cloud from scratch series where I have explained what a network engineer should know in cloud. Because at the end of the day, what you are doing here is you are moving your servers into the cloud, and into the cloud also there is need to be creating those networks which we call the virtual private network, right? Or virtual private cloud. Once your virtual private cloud is there, the requirement is going to be same. You need to connect that servers or the cloud infrastructure back to your campus and branches or data center. So there is a need, there is a work involved where you should understand networking in cloud. Please go ahead and check my series which says cloud networking from scratch. Please have a look at it, so that by the time we reaches to 24 hours of this lecture, you are aware of the cloud also, right? Or the cloud on RAM solution also. The third thing is security, which we just discussed. Why we are doing all these things, why we cannot do just direct internet access. The direct internet access we cannot do, and the reason is that if we open this branch to internet, right, whatever the internet I have, if I open this branch to internet, it means that I am inviting the bad guys of internet to this branch, because now it is open, right? Why you have given internet access from your only data center? And the reason was that you want everybody should come to my firewall first and then goes to internet. Anybody who's coming from the internet should go my firewall first and then go and reach out to other resources of my enterprise, right? That security is not going to be there. So can I put a firewall at every branch? It is going to be costly solution for me. I cannot do that. But what if I can do everything with the same security policies? Then it is going to be a viable solution which we are going to. So security is another concern. We cannot place a firewall at every branch to increase the experience, right? We cannot do that. So although many enterprise who doesn't have this budget restriction can have done that. Now we are talking about deployment challenges, and this is one of the important thing, right? Suppose as I mentioned, Mr. Parth business is growing, right? They have maybe 200 or 200 branches, and now he is going to introduce 50 more branches, right? What exactly the process you follow for these 50 more branches? You buy one router, right? You put all the necessary configurations sometimes into this, then you ship this router to that branch, right? When this branch is, and then you say, because most of the remote branches, suppose you are a network engineer, you have bought this device, and this remote branch is almost 2000 kilometers away from you, right? You have configured this device as a network engineer, you have sent it. And now you are saying in that remote branch there are 5 or 6 users who do not know anything about networking. And then you say, can you log into this device because your configuration are not working? Then you ask them, log into this device, can you show this command? And there is a wastage of these people time also. And believe me, all this time, whatever you are taking time in procurement, putting that configuration, and if that configuration does not work, then it's a problem in terms of time. So for these 50 branches, if you are doing something in parallel also, maybe it is going to take 6 to 7 months of time, right? I am saying the ideal scenario. But yes, if you have automation capabilities, that of course you can reduce this time, but you need to build that automation on your own, right? So deployment challenges are there. There is not a single pane of glass from where you can manage everything from the WAN right now, right? All the tools exist, but those are not, I would not say that those are single pane of glass for your complete WAN infrastructure. Whatever you want to do, you can do from a single place. I do not see that in many cases, right? Now, the last thing which I have already explained, the management challenge, where I want to mention that whatever this thing is, whatever your WAN infrastructure is, right? You can have multiple tools. You can have multiple automation tools who can manage your WAN. But believe me, I do not see in legacy enterprise a single tool which can manage everything, which can deal with all the router switches, whatever you have for this WAN, which can deal all the transport links. And that is why WAN management is one of the tedious tasks in traditional enterprises. Because as your enterprise grows, you see a lot of challenges, a lot of problems. It is as simple as that. So we have application performance issues, we have cloud connectivity issues, and there couldn't be chances of DIA because the security policies are at the data center. We have security issues, we have deployment challenges, we have management challenges. Now, let's try to solve everything without introducing SD-WAN. Okay. I am saying that I will be introducing SD-WAN here, but now let's try to think. Let's do not discuss SD-WAN now. Let's try to think how we can resolve, how we can solve all these issues, what we need actually to solve all these issues. Okay. So right now I can see Kapil has a hand raise. Yes, Kapil, please do ask your question.
Hello.
Yeah, Kapil. Okay, perfect. I don't think we have a question. So no worries, no worries.
Hello.
Yeah, anybody? Yeah, Raj Sharma,
Yeah,
please.
this is Raj. Actually, sir, I have a question. Uh, for monitoring purpose, although we have some technology, we can configure IPSLA, which used to track the jitter delay
Mm-hmm.
For the network.
Mm-hmm.
So we can use the same technology. Why we are using we are
Why we are using
investing
SD-WAN?
our
Yeah,
yeah.
I totally agree with you. You can calculate that jitter, delays, and everything, right? No problems at all. You have the tools available. Can you be please on mute, Raj? Because yeah, thank you. Yeah. So the problem here is that the problem is not here that you cannot do all these things, but how efficiently you can do this is the cause here. For example, you can calculate that on each link what is the delay, jitter, and everything, but can you do on the basis of that jitter and delay? Can you monitor for a specific amount of time and instruct your routing protocol to move your traffic? You cannot do that in current scenarios unless you are using IWAN or something. So there is a previous solution which is intelligent WAN, which is capable of doing that, and before that there is a performance routing which is capable of doing that. But believe me, you do not want to configure them because those are tedious solution to configure. Right now, whatever the problems we have discussed, we are going to see from a single pane of glass, you can do everything, right? And that is what companies are looking for: ease of management, ease of deployment, security should be there. There shouldn't be any problem with respect to cloud connectivity. The application is going to be good, and then application performance. I'm not saying that companies are not doing all these things. We are running everything from so many years, no problems at all, right? But as the time grows, as the cloud comes into picture, as the application requirements is increasing, we are seeing problems, right? And we are just patching those problems. Yes, we can monitor and check that whether there is another link, we can shift the traffic. But do you want to do this for more than 1000 link you have in your enterprise? You should not. Then basically you need to hire more staff, more networking staff, and that is where the problem to the business. Sometimes just one advice I would like to give you. Sometimes it is not all about technology. You can solve problem with technology with manpower, but there are more problems with respect to business, whether your business want to include more people or not, right? Whether they want to include more people or more automation. I have seen in my experience that sometime a solution which is not that much capable technically win the race because it is adding more value to the business, right? So it is not always about the technology. You can do all these things, but what exactly SD-WAN is giving you, we are going to discuss it, right? So why can't we do this thing? Let's go through how we are going to solve this problem. What SD-WAN solution look like? Let's go through one or two classes, and then compare that whether your understanding is correct, whether it is adding any value or not. And if it is not adding any value, then it's a problem. Okay. So let's try to solve. The first issue was application performance issue, right? So if I compare this issue, it is as good as, suppose I am A and this is my house, right? And then I want to go to my office, which is several kilometers away, and there are several paths to it. This is the yellow one, then a white one, and then basically my right one. There are several paths available, right? I am not sure which path is going to be great. I know that this white color path is only 5 kilometers away. This one is approximately 10 kilometers, and this is 7 kilometers. So generally I take this path, but sometimes I face issues because in this traveling this 5 kilometers can take sometimes to 1 hour or sometimes to only 30 minutes, right? So what generally you do, you open Google Maps and you see which path is efficient for me, right? And believe me, sometimes although the length or the distance between your office and your home is only 10 kilometers, is the farthest one, the 10 kilometers, but this path is good because somebody is showcasing you that you can reach here in 25 seconds, sorry, 25 hours, right? Not even hours. I'm doing so many mistakes in terms of time today. So 10 kilometers and you can reach only in 25 minutes. So of course, this path is better. If you want to save time, you are going to choose this path for sure. But the important part is that there is somebody who can guide you, or which you can see that there is an eye in the sky, right? Who is watching all these links and informing you, although this link has so many, this link is longest one, but you can reach in a shortest period of time, 25 minutes, because there is no traffic at all there, right? So we need something who is watching all these links from top, right? And guiding us that which link is better. And if his link is better, then basically we can shift our traffic towards that link. So suppose we have a smart device here. He's pretty intelligent, right? The duty of this smart device is that it is collecting all the values from these links, all the links in your WAN, right? It is a very smart device. He's polling that what is going on. He's calculating the delay, he's calculating the jitter, it is calculating the, what is the third parameter, guys? Delay, jitter, and anybody? Come on, just
Latency.
perfect. Delay, jitter, and latency. What is the difference between latency and delay? The third thing is packet loss. So the latency you mentioned is exactly the delay, no problems at all. So delay, jitter, and packet loss, it's going to calculate all over all these values on this link for a considerable period of time. Maybe he has a window of 1 hour, that how this link is behaving in this particular 1 hour, right? And now you can instruct this smart guy that if this MPLS link is having less than of 90 milliseconds or more than of 90 milliseconds of delay, I want to shift my traffic to internet, and I can do that, right? But the important thing is I need somebody who can see every WAN link and then accordingly can take decisions also. But yes, to take those decisions, we need to feed some information into this smart device, right? That of course, this is my application. My application is maybe application number 1. He has these requirements. If the traffic is less than, it's greater than, delay is greater than 90 millisecond, or maybe the packet loss is greater than 1%, 2%, this application is not going to work. So move this traffic from MPLS towards the internet, right? The second thing is cloud connectivity. The solution, the potential solution is that it is going to be great if this branch can access this cloud via the direct internet, direct connectivity. Can we do that? We can do that if this device, whatever we are going to put here, the router, is capable of doing firewall, has some firewall capabilities also, right? If we have that, then we can configure the similar policies, whatever we have in the data center, so that this traffic, so this guy should not go out and reach to data center first to reach out the cloud. It is as simple as that, right? So it means that we need direct internet access with that security. If we can provide that, we can solve this problem. Now, the deployment challenge. Wouldn't it be nice that if I am opening a new branch, suppose not here, if I'm opening a new branch, let's say somewhere here, and I have shipped a router without any configuration in it, right? And what I am doing is just connect this router to a transport, to any transport. And what this router is going to do is, it is this router's responsibility. You just need to power it on. You just need to connect this interface to the transport. And what this router is going at the back end is, it is taking all the configurations from the centralized location, right? It configure everything, whatever is needed. And then it is within no time, with 5 or 10 minutes of time, it is up and running, and all the users who are sitting here behind this router can access your data center and everything. So all the policies, whatever is needed, everything is on this router itself, right? So that job of 5-6 months, you just need to do is, you just need to ship that router to that branch and make sure that you attached a right cable and then power it on. And that is what you need. Once you are done, your branch is up and running within no time. And actually, we are seeing this in actual deployments, that whatever the planning you need to do, what configuration should be pushed into this device, what are the policies, you can have that plan in a centralized location. And when this device comes up, it is going to fetch its own configuration. It is up and running within no time, right? The last challenge, wouldn't it be nice that if we have a centralized server which can manage all my WAN infrastructure, everything, in just one server through one single pane of glass, right? And if I have that, I can log into this device, I can see my current, absolutely everything in my WAN infrastructure, and if I can manage it, I can solve many of the problems, right? I will be showcasing you everything when we are going to read about SD-WAN in detail, how these problems are going to be solved, right? And believe me, all this problem can be solved through SD-WAN solution. I'm not talking about only Cisco's Viptela. I am talking about any SD-WAN solution, whether it's a Versa, Silver Peak, or anything, right? All these all these solutions are capable of solving whatever the challenges we were facing in our traditional enterprise, right? And this is the whole sole point of this complete course, that we should understand there were problems in traditional enterprise, and it is not the case that they cannot be solved, but how we are solving them efficiently is the gist of this SD-WAN course, right? So, because if you say deployment, most of the guys who are from the automation background, they say deployment challenge is not a problem for me. I can just build a script. Whenever this device comes up, it will take the configuration. It will start up and running in no time. But what do you think, that do we have such kind of automation tools available for every enterprise? Will every enterprise is capable of doing that? I'm pretty sure that we cannot. Means maybe in some enterprises we have automated solution, but it is not the case with everybody, and that is why we are coming up with this SD-WAN, the fully automated solution. You just place your device, it will take the configuration, everything, and it is going to be up and running. I'll give you an example from my experience. See, I have built 3 or 4 data center for a particular customer, right? Okay, I'll take this board. Pretty interesting thing, right? So these 4 data centers were, and I'm talking about when I didn't know SD-WAN. So all these data centers were connected. These are in different regions, Asia Pac, Americas, and then Europe region, right? DC1, DC2, everything is connected. So whenever, and there are so many devices inside these DCs also which are connected, right? So whenever I do a little bit of change, any change, for example, whenever I bring this data center and put this into the production, right? It take hell lot of time. I need to prepare configuration for some of the devices. Then I take maintenance window, right? And that maintenance window sometimes goes to 12 hours, because if something goes wrong, we need to debug it. And I have seen that this maintenance window was approximately from 6 to 12 hours long. And I have seen into many, right? But believe me, there is the WAN guy who was doing this SD-WAN, right? Although they plan it well, but their maintenance window, because whenever this DC is coming up and running, we want to make sure that DC is part of our WAN infrastructure also, so that other branches can reach to this DC. And who is managing that? Who is managed by SD-WAN. And believe me, this guy, maintenance window, whenever they bring up any branch or many branches at once, those maintenance windows are only for 10 to 15 minutes, and that is it. Whatever the template, whatever the configuration, they push it, and these branches are up and running in no time. So I envy them that I spend approximately 6 to 12 hours in every maintenance window, and you have done all these maintenance window in 10 to 15 minutes without any problem, right? And that is the power of automation, believe me. So we are going to discuss all these things with you guys. And now the next board come. Till now, what we have done, if I summarize, till now we have understood what WAN is. Till now we have understood basically how this WAN has been evolved, right? We understood the problems in legacy or enterprise network. We understood what and how an enterprise network looks like, right? We understood all these things, and we tried to solve all the problems also, how we are going to solve it. I haven't taken any name of SD-WAN till yet, no controllers, nothing, right? But what we are going to see here is, we are going to, what should be the approach of learning this SD-WAN, right? So I will be discussing some part of this approach. The approach is going to be, first thing first, we are going to presume this SD-WAN is a big puzzle. This is a big puzzle, what we have right now. And if this is a big puzzle, generally what we do to solve it, right? We are going to break it down into multiple pieces. We are going to understand these multiple pieces. We are going into the detail of these multiple pieces, right? So when I broke down this SD-WAN, it gave me three pieces. One is if you understand control and data plane. The second thing is if you can understand the concept of next hop. And the third thing is if you can understand tunneling. And believe me, if you understand just these three concepts, SD-WAN is going to be a piece of cake for you. It is not going to be a problem at all learning SD-WAN, right? So what we have done is we have broken down SD-WAN complete puzzle into multiple puzzles, right? Multiple smaller puzzles. We are going to give a complete attention to these small puzzles. We are going to solve it, and then at last we are going to combine it to build this complete SD-WAN solution knowledge. That is it, right? So having said that, I can start this right now because I have everything on my board, and that was the plan also. But as I see that, and guys, believe me, I do not care much about the time. I need to make sure that you understand these things, but I appreciate that you are spending your time. So I do not take care about, I don't take much care about my time. So it is okay that if this course of 24 hours can go to 28 hours, but I want to make sure that everybody understand the concepts well. Okay, so right now, as I see, the 2 hours are already been completed, and I want to take some questions from you also, right? So what we are going to do is in next lecture, whatever the three puzzles we are discussing, the control plane, data plane, control plane, data plane, not four, only three. First is control and plane and data plane. The second one is tunneling. And the third one is our next hop concept. We are going to discuss all these things in the next class, and then we are going to combine them together to build a SD-WAN solution, right? I want to make an announcement today that tomorrow we are not going to have a session on SD-WAN. There are some reasons for it. And from next week onwards, we are going to continue on the weekends, right? So I will be sharing this recording pretty soon with you. Maybe it is going to take 1 or 2 days to edit this and to send it to you. But now I am open for the questions. Please do ask any questions. Please try to add whatever I added here. Is because I have seen comments from Ted, comments from Burak that they want to add something. Please, if you want to add something, do add. You are more than welcome. You are most welcome. And then if there is any question is coming into your mind, doesn't matter, ask me in Hindi also if you are comfortable in that. And then basically I will convert it for other audience. But do not shy away. If you do not ask questions in these sessions, it is not going to be very beneficial for you guys, right? Whatever is coming to your mind, because we literally started from what WAN is. So do not shy away, right? Here are a lot of people sitting with me who have having experience of 25 years, 20 years, 15 years, right? And they must be thinking that what Vishnu has done in this first session. But believe me, we always start from scratch, right? And that way, basically, this is my message to everybody. Do not worry about what is coming to your mind. If there is a problem, even in this class, if you do not get what 2 plus 2 is equal to 4, if I mention somewhere this, and if you haven't gotten it, please do ask. Otherwise, there is no point of having this course. Okay, so I am open for question now. Next 15-20 minutes I will be available. I am open for question. Please do ask any question and I will be happy to more than answer. Or if you want to add something. It's all up to you now, guys. No questions? Senthil, Rakesh, Raj, Parth, Manikaran, anything to add? Okay.
Hey, hi Vishnu, Arun
Yeah,
here.
Arun.
So just one thing is coming to mind. So the WAN connectivity, the technology that uses, right?
Mhm.
So is it something that we are? I mean, I'm not sure if it's an early to ask this question or not, but the technology that we are going to use is going to be replaced by this, or the technology remains the same. Only the way we are connecting changes.
Actually, we are not disrupting what exactly you are using right now, right? So MPLS transport is going to be there, internet transport is going to be there. We are building on top of it, right? So
So
sometimes I usually see this, that is SD-WAN technology is a competitor of MPLS. I would say it's complement MPLS, right? Because at the end of the day, you need transport, you need underlay, and then basically you are going to build it, right? But yes, with the with SD-WAN, I could see that the previously we were used to buy a lot of MPLS circuits so that there is a stability in the network. But yes, there is going to be decrease because now there is internet transport which also doing very good, and we have a scalable solution. We have an intelligent solution which can move our traffic. So I don't say that we are going to remove your existing things. These are going to be there, but we are building on top of it. But yes, you can remove some of your those costly connections which are not required after this. Okay.
sure,
Yeah.
yeah, got it.
Anybody else?
So this is Raj. Actually, I have a question, but not related to SD-WAN
Uh-huh.
for the first
Uh-huh.
class. Means I have a question not related to
No
SD-WAN.
problem. Ask it.
Should I ask?
Yeah. Yeah.
Actually, I have a query like, what is the difference between MSS and MTU? Basically, MSS, the packet more than MSS size will be just dropped, and the packet more than MTU
By
will be
by any
fragmented.
chance,
I
by
believe.
any chance, you are part of my TCP class, Raj?
Uh,
No. So
TCP.
this topic is going to take from 15 to 20 minutes, or maybe sometime 30 minutes.
Oh,
And believe me, I
oh,
am going to explain this in tomorrow's TCP session, right? So if
okay.
I want to give an idea about it, that we this TCP course is of 12 hours, right? We have already done with 6 hours. 6 hours are already completed for that. Tomorrow we are going to discuss error control in that, and in error control, because there is a lot of requirement from in terms of what exactly MSS and MTU is and how it is calculated, why it is important. I am going to explain you tomorrow. Just sit on this class of TCP, and because otherwise it is going to be wastage of others' time if I do it right now. But yes,
No,
this is going to be 30 minutes discussion, and believe me, you will have your concept clear. We'll send you the link for tomorrow's class, and
okay,
you can just come and join it. Okay,
okay.
no problem.
Thank you so much, sir.
Anybody else?
Yeah, hi Vishnu. So one question, that what is DMVPN? You mentioned in one of the slides with
Yes, yes.
IPsec.
So just now means right now, most of the cases, most of the places you are seeing DMVPN solution, right? So what exactly DMVPN is? Right now, as I mentioned, we have a data center, we have several branches. The first thing first is it is a WAN solution, just like SD-WAN, right? So Mr. Parth, who is interested in connecting their branches with data center, right? We have branch number 1, we have branch number 2, we have branch number 3, right? So what exactly going on? Suppose we have internet connectivity between them, right? So what you're going to do is you want to connect your data center to branches. How you can do this? You have bought these different connections, and now you want to run your IPsec over it. So first you are going to build the GRE tunnel, right? And then basically you are going to encrypt it. So one way is basically you can do it manually, both these things on every circuit. And the other thing is you can do using DMVPN. DMVPN is a multi-point GRE with IPsec. What is the meaning of multi-point GRE? The multi-point GRE is that you do not need so much configurations. You with some with few configuration commands, you can create a multi-point. Generally, a GRE tunnel is a point-to-point, but you can create a multi-point tunnel. Here is only one point, and then basically you can have connectivity like this. All these are your GRE tunnels, and then DMVPN solution placed. Basically, you can create IPsec on top of it, right? So basically, whatever we are going to do from in SD-WAN, if we go one step back, we have DMVPN solution, right? DMVPN solution is creating these GRE multi-point tunnels. Then basically you can run any protocol, BGP, MPLS on top of it to exchange these routes. But as you can see, most of the things are manual here. For example, you can create this tunnel, but what protocol you are going to choose? Maybe you want to choose OSPF or EIGRP, which are going to run on these tunnels. Why you are running OSPF or BGP on top of it? Because you want to exchange this route. For example, y.y.y.0/24 is here. You want to see it here, right? So on these IPsec or GRE tunnels, which is created by DMVPN solution, right? Which is created by DMVPN solution. Here, you are going to run this OSPF, and this is your choice. What do you want to run, right? So this is a manual solution, you can say. Although these tunnels are automatic, you can configure in DMVPN that what tunnel should come up, right? But all these protocol choice, you need to do that. You need to configure everything, right? But if you go one, that is what I said, that if you have a DMVPN solution up and running, right? Whatever the DMVPN technology is, if you give some injection, the steroids injection to it, right? This will become SD-WAN. So what we are doing in a DMVPN solution is we are adding more automation, right? You should not be able to select this OSPF or BGP, whatever you want to run. We are giving you a ready-made protocol. You should not be worried about this, how these tunnels are going to be up and running. These are going to be up and running on our own. You just need to place this device here, and this will start forming these tunnels and will part of your fabric, whatever the network you have created, right? So DMVPN is just a step back, if you can say, just one step back from SD-WAN. We have been using it, but it is more manual approach, right? As compared to SD-WAN, it is a single solution which can do everything from a single UI, right? But at the end, it is creating the DMVPN-like architecture, but more efficiently. So I'm saying, and yes, there are some things also which are not there in DMVPN. For example, application-aware routing was not there, right? And what is application-aware routing, which we discussed, means based on delay value, based on packet loss or jitter. Basically, SD-WAN solution can take decisions, right? You can do this thing also, but manually in DMVPN. So I hope I am able to answer your question, Mr. Arun.
Got it.
Okay.
Thank you.
Anybody else?
Hi Vishnu, Kapil this side.
Yeah, Kapil.
When deploying new branches is like that plug and play.
You are right. So the question is basically whenever you deploy a new branch, then if you place that device, how much effort you are going to put in there. And believe me, we have deployed so many where you just need to put that device, you just need to put a right connection where it is going to get the IP address from DSCP. And if you can do that for me, it is what you needed to bring that edge or to bring that branch up and running. Okay.
Okay, thanks.
Yeah. Anybody else? I am liking the questions. It means that you got something. Senthil, Rakesh, Raj, Parth, Mrina, anybody, anybody. I'm open for the question.
Hey
Okay. Hey,
Vishnu.
Ted. Yeah, you wanted to add something.
Oh, yeah, I've been putting my questions on the chat box. Maybe you can have a look at it later. One of the questions I have
Mhm.
is there much to the transition from the traditional, like for instance, from DMVPN to transition to SD-WAN, like in terms of swapping out hardware or reusing some of the hardware? Is it?
Indeed, it depends on what model, what router you are using. For example, in most of my customer scenarios, right? They have been using they are using some of the devices which are pretty new, right? Although they are not utilizing the capability of SD-WAN right now, but those devices, if you just change the code on these devices, those are very much capable of doing SD-WAN, right? You just need to change the image. You just need to reboot a router into a particular mode, and then your router is able to perform or able to SD-WAN aware, and then basically it can do SD-WAN routing. Okay, so the migration path is going to be that if this GMVPN solutions endpoints or the routers are capable of doing SD-WAN, and we can have the compatibility metrics, we have everything on Cisco's website, or basically if you are using some other solution, they should have the compatibility metrics which showcase that yes, this device is capable of doing that and this device is not, and it's as simple as that. But yes, during last couple of hours, sorry, last 7 or 8 hours, we are going to spend some good amount of time in how you are going to migrate from your existing maybe DMVPN solution or existing WAN infrastructure towards your SD-WAN. Okay.
So that means there's zero traffic engineering that needs to be done on the underlay. Underlay will remain untouched. All you're doing is dealing with the overlay of fabric.
Yes, but sometimes when we create this overlay, people, if I give you an example of a customer, right now their WAN infrastructure is pretty good. They are doing just great, right? They are using so many terms in BGP. They are using AS path manipulation. They are using so many things, right? And we notice that in some of the places we even do not need that all that complexity in underlay, right? Because now your traffic path is actually controlled by your SD-WAN, although the underlay is going to be the same. But sometime, most of the times you are right that the underlay is going to be same, uh, but but sometimes customer says that if I am just doing or changing my WAN, it is the right time to change some of the problems which I have in WAN network. So generally we do not touch the underlay portion. It is right there. It is everything is going to be there, but we are just building this overlays. And to others, if you are not getting the concept underlay overlay, do not worry about it. I am going to tell you in upcoming classes what exactly this fabric is, what overlay is, and why I'm talking about what I'm talking about, that we do not need to touch underlay. We will be going into deeper. Do not worry. But you are right, Mr. Ted.
Thanks, Vishnu. That's all from me.
That is perfect. Anybody else? Okay. So tomorrow there is not going to be any class, but you all are invited to my TCP session tomorrow, right? It is going to be of 3 hour session where we are going to discuss this error control. It is going to be great because I literally worked hard on that, and have some Wireshark captures also for you so that you can exactly see how this error control happens at the transmission control protocol, right? We are also going to discuss how this MSS and some part of IP fragmentation also, because these are the topic which is haunted which are haunted for many people, right? So do not worry about them. If you want to join, just reach out to me and just join tomorrow's class. Having said that, thanks for being a wonderful audience, and I really like talking with you, seeing so many people. Although people haven't joined, some people couldn't join because of last time engagement they have, but let's meet next week, and I'm pretty sure that we are going to learn this SD-WAN to its core. Okay, having said that, bye bye for now. See you later.